A previously unknown species of giant dinosaur has been discovered in Spain. In a recent study, scientists from Spain and Portugal described a previously unknown sauropod that lived about 122 million years ago on the Iberian Peninsula. The new species was named Titan morelensis and could have reached a size similar to titanosaurs, which were one of the largest animals in the history of Earth. Bones of Titan morelensis were found during excavations at the site of Sant Antoni de la Vesap near the town of Morella, Spain, in 2005 to 2008. Researchers have unearthed the fossilized remains of at least 3 individuals. The finds date back to 122 million years ago, i.e. the early Cretaceous period. The results and description of the research were published in the Zoological Journal of the Linnean Society. The new species of dinosaur, Titan morelensis, belongs to the group of sauropods, 4-legged, herbivorous dinosaurs with long necks and tails that could reach gigantic sizes. Fossils of this species were found at a site in Sant Antoni de la Vesap. This is one of the largest concentrations of fossilized remains of European sauropods. One of the individuals we found is distinguished by its large size. It has vertebrae over 1 meter wide and a 2-meter femur. At this site we found 2 almost complete feet, which is particularly rare in the geological record, says Pedro Mocho, a paleontologist from the University of Lisbon who led the research. Based on the size of the excavated bones, scientists estimated the size of the animal. According to researchers, the largest of the individuals found could have been similar in size to titanosaurs, which were one of the largest animals in the history of Earth. Among titanosaurs, the largest species described were Argentinosaurus huinculensis and Patagotitan majorum, both of which probably weighed at least 70 tons. The published article contains a detailed description of the fossil remains found in Sant Antoni de la Vespa. Scientists also identified a set of anatomical features that distinguished this species from other sauropods. Titan morelensis has unique morphology of the femur and the elements that make up the foot. The femur, as researchers admitted, is more similar to the femur of sauropods from the late Cretaceous. In the study, scientists also analyzed the relationships of Titan morelensis and other early Cretaceous sauropods from the Iberian Peninsula. Titan morelensis is one of the most primitive representatives of the Somphospondyli group, which belongs to one of the most diverse and numerous groups of the Cretaceous period and which became extinct at the end of the Mesozoic. Fossils of this group can be found on every continent, but until now it was unclear where exactly they came from. Scientists suggest that the discovery of this primitive species in Spain suggests that Europe may have been the place where these animals appeared. This study highlights the enormous complexity of the evolutionary history of Cretaceous European sauropods, which were related to lineages found in Asia and North America, as well as some groups from Africa. The research results suggest the existence of periods of fauna spreading between these continents. Future recovery of all fossil materials found at the site will provide important information for understanding the initial evolution of this group of sauropods, which dominated the dinosaurs during the last million years of the Mesozoic era. A mysterious explosion between galaxies. Astronomers using the Hubble Space Telescope and other observatories, including Gemini Observatory, have discovered a powerful but poorly understood type of cosmic explosion called LFBOT, luminous fast blue optical transients. although researchers have observed several such phenomena so far. The latest one seems to have its source between galaxies, and not in a star-forming galaxy, like the previous ones. This observation challenges leading ideas about the origin of these explosions. LFBOT explosions, luminous fast blue optical transients, are some of the brightest known visible light phenomena that we can see in the universe. LFBOT was first observed in 2018 and has only been spotted a few times since then. Currently, they are detected about once a year. The most recent phenomenon of this type was recorded in April this year. The results and description of these observations have been accepted for publication in the monthly notices of the Royal Astronomical Society, and are currently available in the archive.org preprint database. The 2018 explosion was extremely intense, much more powerful than the average supernova, and 10 to 100 times brighter. She was designated AT2018 Cow and from then on was simply called Cow. The Cow was the first example of a new class of astronomical phenomena, LFBOT. So far, only a few of these peculiar events have been confirmed, and each has been given a zoological name inspired by the last few letters of its astronomical designation. Currently, in this peculiar zoo, apart from the cow, we also have a camel, a koala and a Tasmanian devil. The newest LFBOT received the designation AT2023FHN and was named Z-bar. However, the physics behind these phenomena remains a mystery, and the latest observations raise more questions than they answer. After its initial detection, the newest LFBOT was observed by multiple telescopes across the electromagnetic spectrum, from X-rays to radio waves. It showed all the characteristic features of the LFBOT explosion. It glowed intensely blue and evolved rapidly, reaching maximum brightness and fading out within days, unlike supernovae which last for weeks or months. But Z-bar showed an additional, unexpected feature. Unlike other phenomena of this type seen before, Z-bar exploded between two galaxies, about 50,000 years ago. Light-years from the spiral galaxy and about 15,000 light-years away from the smaller galaxy. Not only does this discovery disagree with the locations of previous explosions that have occurred in star-forming galaxies, but it poses problems for some existing explanations for the origins of these phenomena. Scientists assumed that these explosions were a rare type of supernova in which the core of an extremely massive star collapsed. But the giant stars that turn into such supernovae have short lifespans by stellar standards, which means that no such star would have time to travel that far from its host galaxy before exploding. Since Cow was discovered in 2018, astronomers have been searching for more of these mysterious events. Because these phenomena can occur anywhere, time and are relatively fleeting from an astronomical perspective, researchers rely on observations that can continuously monitor large areas of the sky. It was thanks to them that Z-bar was spotted. After detecting the Finch, researchers launched a pre-planned surveillance program that was on standby to quickly focus attention on potential LFBOT candidates. Thanks to the involvement of many observatories, it was possible to learn some features of this phenomenon, for example the fact that Z-bar reached a temperature of 20,000 degrees Celsius. In addition to speculating that LFBOTs are a particularly rare class of supernovae, scientists have a few other ideas about how these phenomena might form. Some researchers have suggested that they could, for example, be created by a black hole tearing a star apart, but Primes said a black hole wouldn't be expected to be found so far from the galaxy. Z-bar's unusual location suggests that it may have been the explosion of an extremely fast-moving star. Alternatively, it could be the culmination of a much longer process. such as the collision of two neutron stars that have been spiraling towards each other for billions of years, although this is only speculation. 2 years ago, research by scientists from the Massachusetts Institute of Technology appeared, which suggested that a black hole or a neutron star was born at the site of the cow explosion. This discovery raises many more questions than it answers, Crimes says. More research is needed to find out which of the many possible explanations is correct, he adds.